Scientists and philosophers have spent centuries researching and discussing the vast and diverse subject of the universe's history. The Big Bang Theory, which proposes that the universe began as an incredibly intensely hot and dense explosion around 13.8 billion years ago, serves as the cornerstone for our current understanding of the universe's history. In this video, we will explore the history of the universe in a nutshell. The universe is the total matter and energy system of what we see and know today, of which Earth is a component. Its fundamental constituents are galaxies made up of stars, stellar groupings, and nebulae. The Milky Way galaxy includes billions of stars, including the Sun on Earth. The universe contains all atoms, subatomic particles, and their constituents. The four fundamental forces that govern the universe are the weak force, strong force, gravitation, and electromagnetic force. The Cosmic Background Explorer satellite's instrumentation revealed in 1992 that 99.97% of the universe's energy was emitted in the first year following its birth. This information appears to support the Big Bang Theory, which states that the universe was created by one cataclysmic explosion of a minuscule amount of intensely hot and dense matter known as the Big Bang. Astronomers believe that 99% of the universe's matter is dark matter, which is made up of dark or invisible matter that is hard to find. The details of what happened at the moment of the Big Bang are not subject to any commonly accepted theory. Using current physics theories and principles, we can deduce that the universe had infinite temperature and density at the precise moment of creation. This implies that no physical theory can explain what happened during this period. In the first minute fraction of a second after the Big Bang, the universe went through a phase of tremendous expansion known as inflation. The most plausible hypothesis is that the cosmos appeared and then expanded at an extremely high rate in the first minuscule fraction of a second. The cosmos has continued to stretch and cool since then. Due to the high heat and density, the universe was built up of a few distinct particles in this minute fraction of the first second. You've probably heard about the recently discovered Higgs boson, which can be seen for a split second in the harsh conditions produced by particle accelerators, like Switzerland's Large Hadron Collider. These are not visible under normal circumstances. The Higgs boson most likely existed in the first minuscule fraction of a second of the Big Bang. Even though the temperature was close to 1 trillion degrees Celsius, the universe began to cool and expand swiftly as soon as it reached a second old. As a result of this expansion, the universe cooled and stretched, resulting in the formation of subatomic particles such as protons, neutrons, and electrons. Because atoms cannot exist at such extreme temperatures, neither of these particles could link to form atoms. Approximately 10 seconds after the Big Bang, the universe had cooled to 1 billion degrees in temperature. This temperature is suitable for the existence of atomic nuclei. The universe served as a giant nuclear reactor. Hydrogen nuclei became converted into helium nuclei in 3 stages. The reaction has 2 unique pathways, yet both lead to the same result. 2 protons and 2 neutrons unite to form a helium nucleus, which emits a large amount of energy. Finally, these particles bonded to form atoms, predominantly helium and hydrogen. The universe became translucent due to the absorption of free electrons during this phase, known as recombination. The light emitted at this epoch can now be detected using the radiation from the cosmic microwave background. However, before stars and other light things were formed, there was a period of darkness following the recombination phase. The universe constantly evolved over the next billions of years. In the early universe, the matter was drawn gravitationally to higher density regions. This gravitated matter subsequently became galaxy clusters and elongated filaments of gas and dust, resulting in the breathtaking filamentary cosmic web seen today. As the universe expanded, matter began to build up due to gravity, giving rise to galaxies and stars. There is still a lot to understand about how galaxies, which contain hundreds of billions of stars, originate. The bottom-up theory, which has recently acquired popularity, is one such theory. According to this theory, a gas cloud in a galaxy collapsed into a yellow star with a ring system surrounding it. These rings eventually merged to form the star system that we live in today, including the 8 planets and several moons, comets, dwarf planets, and asteroids. This theory either resulted in Earth, the planet third from the central star retaining a considerable amount of water, or comets subsequently transporting a flood of ice and water to the planet. A lot of small galaxies constantly get swallowed up by larger ones as the universe expands. The Sun and our solar system's 8 planets, including Earth, originated around 4.5 billion years ago. Our solar system originated approximately 8.9 billion years after the Big Bang, giving it an age of about 4.5 billion years. The Sun circles around 24,000 light-years from the galaxy's center and is one of over 100 billion stars that comprise our Milky Way galaxy alone. Many scientists believe that the solar nebula, a vast spinning cloud of gas and dust, was responsible for the development of the Sun and the rest of our solar system. And as gravity caused it to compress, the nebula began to spin faster and flatten into a disk. Throughout this phase, a bigger portion of the material was drawn into the center, resulting in the formation of the Sun. Our Milky Way galaxy is said to have formed a little more than 1 billion years ago. Smaller galaxies that the Milky Way has absorbed throughout its long existence are still there as remnants within the Milky Way. The Milky Way is actively digesting at least 2 tiny galaxies, and possibly more will get dragged in over the next 100 million years. Old stars, also known as population 2 stars, are found in a halo surrounding the Milky Way and primarily contain hydrogen and helium elements. The heavier elements were possibly discovered in the early population 3 stars that exploded. Planets are formed when the byproducts of materials of star creation are combined. Rocky planets like Earth, Mars, and Venus cannot orbit population 2 stars because elements like iron, oxygen, and silicon are only present in trace amounts. The Sun and other younger population 1 stars can be located in the disk and the bulge at the galaxy's center. These have a higher concentration of heavy elements and are expected to be host to numerous planets. Over the next billion years, stars and galaxies continue to form and change. Some stars eventually ran out of energy and died, triggering nuclear fusion and the production of heavier elements. These heavier substances, such as iron, oxygen, and carbon, eventually created planets and other planetary systems. The Earth's environment eventually improved to the point that life could flourish, allowing single-celled organisms to emerge initially, followed by more complex living forms such as plants and animals. The current diversity of life is the consequence of many different diversities of life evolving and becoming extinct as the planet's climate and environment change over time. Humans are one of the most recent species to originate on Earth, with a roughly 200,000-year history and noteworthy achievements in culture, science, and technology. Astronomers began to theorize in the 1960s and 70s that the universe may contain more mass than what is seen with the physical eyes. Vera Rubin of the Carnegie Institution of Washington measured star velocities in various galaxies. Rubin detected no difference in the star's velocities further out, contrary to what fundamental Newtonian physics would predict, if stars in the core and periphery of a galaxy orbited at different rates. She noticed that each star in a galaxy appears to orbit the center at a fairly constant speed. This mysterious and unseen mass is known as dark matter. Dark matter is said to exist due to the gravitational influence it has on other types of matter. The unknown mass is said to be formed by distinct particles that do not interact with light or ordinary matter, explaining why it has been so challenging to detect. According to our current understanding, the universe appears to be expanding and speeding up. The speed is currently assumed to be caused by a mystery component known as dark energy, while scientists are still striving to determine its exact origins. astronomer Edwin Hubble made a groundbreaking breakthrough about the universe in the 1920s. While utilizing a newly developed telescope at the Mount Wilson Observatory in Los Angeles, Hubble determined that the universe is expanding rather than remaining static. Years later, in 1998, the Hubble Space Telescope, named after the famed astronomer, determined that the universe used to grow more slowly than it does now. Scientists were taken aback by this discovery because it had long been expected that the universe's gravitational force would cause it to slow down or possibly stop expanding. The mysterious and unexplained dark energy is said to be the strange force pushing the cosmos apart at breakneck speed. The presence of this unknown energy, which is said to make up 80% of the universe, is one of the most fiercely disputed subjects in cosmology. Well, the story does not finish there. The history of the universe is one of development and change, from the hot, dense singularity of the Big Bang to the formation of stars and galaxies, and finally to the appearance of life on Earth. Scientists are still studying and trying to understand the universe's history. Despite the quantity of knowledge collected, many mysteries about the universe's origin and evolution remain unresolved. Even though dark matter and dark energy remain among the greatest mysteries, cosmologists continue to explore the cosmos to discover more about how the world came to be. In one conceivable future scenario, the universe will keep expanding endlessly, long enough for all the stars in all the galaxies to run out of energy and even black holes to fade into oblivion, leaving behind a lifeless universe full of inert energy. Or the gravitational pull will finally overwhelm the expansionary force of dark energy, bringing all matter back together in a process known as the Big Crunch, which is a form of reverse Big Bang. Dark energy could also hasten the universe's dispersion, resulting in the Big Rip, in which the universe splits apart from the inside out. In addition to continuing to search for elusive dark matter, the James Webb Space Telescope, which launched in 2021, will also use its infrared instruments to look into the past and study the evolution of the universe. We can better understand the universe's origins and evolution by studying its history, which is an interdisciplinary subject that draws on the study of physics, cosmology, astronomy, geology, and biology. Since its mysterious beginnings, the universe has expanded at an ever-accelerating pace, leaving us to marvel at its vastness and complexity. The estimations of cosmologists suggest that photons, the oldest known remnants of the Big Bang, have traveled a distance of 47 billion light-years to reach us. This implies that the observable universe spans 93 billion light-years, give or take a few light-years. Such a vast expanse houses an array of celestial phenomena, including quarks, quasars, stars, planets, nebulae, black holes, and all other detectable entities. Nonetheless, this vast universe encompasses only the light that has been able to make its way to us, leaving us to ponder the unknown beyond the observable horizon. How can we even fathom that the universe spans 93 billion light-years if it is only 13.8 billion years old? Can light travel that distance in such a relatively short amount of time? These perplexing questions and uncertainties are the very essence of physics, and delving into their intricacies is fundamental to understanding what exists beyond the observable universe and whether we can ever access it. The question of what exists beyond the universe is perplexing, as the concept of the universe itself is challenging to define. One commonly accepted theory is that of the observable universe, defined in terms of the speed of light. The observable universe is limited to the extent that the light emitted or reflected by objects within it has had time to travel to our position in space. This means that our ability to observe the universe is limited by the finite speed of light and the finite duration of the universe's existence. It is worth noting, however, that the observable universe is not a static entity, but rather constantly expanding. As such, the boundary of the observable universe is not a fixed point in space, but rather a dynamic, ever-changing frontier continually pushing outwards as more light becomes available for us to observe. This expansion is sometimes referred to as the Hubble volume in honor of the famous telescope that has provided us with some of the most distant views of the cosmos. The Hubble volume is another theory of what may exist beyond what we can observe. The current astronomical hypothesis is that the universe might extend infinitely, with an almost uniform distribution of energy, galaxies, and other celestial bodies, similar to what is observable. If this theory is accurate, the implications of what lies beyond are mind-boggling. Imagine traveling beyond the Hubble volume and discovering more than just alternative planets. Eventually, you'll come across every possible thing in existence, and I mean everything. It is an idea that will leave you stunned if you try to grasp it. A more prevalent theory proposes the existence of a multiverse, with innumerable universes that exist as bubbles floating alongside one another. Each universe is unique and represents an alternative reality. Given this theory, and its implications regarding infinity, it would not be unreasonable to suggest that there exists a universe that is identical to the one in which we live, except that you are employed as a roller skating clown. Similarly, there is a universe where you were never born, and yet another where you are a serial killer. Travel far enough, and you'll encounter another solar system, where a similar Earth that mirrors every aspect of ours, except for the breakfast you had this morning, exists. Let that sink in. There may be another Earth where you skipped breakfast and another where you decided to skip work or go on a much-needed vacation. The extent of the universe is such that cosmologists predict there's an identical Hubble volume to ours out there, and it's not even that far away. It is closer than we can imagine. The mere possibility of such an occurrence seems far-fetched, but then again, infinity is undoubtedly infinite. Astronomers made an astonishing discovery that left them reeling in shock. They found out that galactic clusters were hurtling in the same direction at a breakneck pace of over 2.5 million miles an hour. But wait, it gets weirder. Further observations in 2010 cemented the reality of this theory, which we now know as dark flow. The confounding movement flies in the face of all the predictions made regarding mass distribution throughout the universe following the cataclysmic Big Bang. So, what could be causing this shocking behavior? One possibility is the gravitational influence of gigantic structures existing beyond the Hubble volume, structures that defy our wildest imaginings. This implies that outside our observable universe, the system of the world beyond is anything but uniform. But what could these systems be made of, you ask? The answer is anything and everything, from massive clusters of matter and energy to unfathomable warps capable of pulling gravitational forces from the outside world. Intriguingly, another plausible theory regarding what lies in the unobservable domain beyond our universe is that it could be an endless, desolate expanse of absolute nothingness. On the other hand, nothingness is essentially incomprehensible to humans, as we lack the cognitive capacity to fully grasp such an abstract concept. We should also know that a vast, dark space does not equate to nothingness. It is a space. The theory of supposed nothingness raises the question of whether it is even plausible for such a boundless realm to exist. Based on our current scope of understanding, everything in existence is finite. Even entities that appear to be infinite are, in actuality, merely near infinity, but never truly attain a boundless state. Discussing the elements beyond the boundaries of the Hubble volume may seem somewhat misleading, for they are still a part of the same universe we are in, maybe a fragment that is beyond what we can see or comprehend. As such, it would still adhere to the same physical laws and constants intrinsic to our universe. However, an alternative narrative of the Big Bang proposes that the universe underwent a post-Big Bang expansion that caused the formation of bubbles within the space's structure. Each of these bubbles represents a region that ceased to stretch with the rest of space and as a result, gave rise to its universe with its own unique set of physical laws. In this bubble theory, space is infinite, and each bubble is similarly boundless, as an infinite number of infinities can be contained within one infinity. Even if it were possible to exceed the confines of our bubble, the inter-bubble expanse would still be expanding at an accelerated pace, rendering it impossible to reach the next one regardless of one's velocity. The theory of bubbles explains the existence of these universes, each of which exists as a separate bubble, disconnected from the others and floating in space. Some people speculate that it might be possible to traverse from one reality to another by passing through a wormhole or a black hole. This brings us to my favorite theory, that we may be trapped inside a black hole. If this were true, you can jump from one universe to another by entering a different black hole. Stellar remnants that come into existence from dying stars imploding under their gravity, black holes possess an extraordinary density that leads to the formation of a singularity. The space-time bent by black holes is so extreme that it engulfs everything beyond the event horizon, including light, making it a point of no return. Much like the unknown abyss behind the event horizon, the limits of our universe remain shrouded in mystery. What if our universe is, in reality, nestled inside one such black hole, expanding at an unprecedented pace, with its edges constantly pushing away beyond our grasp? Could it be the same force that restricts light from escaping a black hole that propels the universe's expansion? The gravitational pull that we observe outside a black hole is, in actuality, a result of an ever-expanding space-time on the inside, pushing the boundaries far away from everything. The expansion of our universe follows a similar trajectory. Nikodem Poplawski, a theoretical physicist hailed by Forbes magazine in 2015 as the next possible Einstein, proposed another fascinating theory. According to him, our universe is a fraction of a much larger universe that was swallowed by a black hole and squashed until it reached an unimaginable density. The gravitational spin heavily impacted the core fragment, causing it to explode violently, giving birth to our current universe through the Big Bang Theory. The event horizon of a black hole is described as the point where the curvature of space-time exceeds the speed of light, making it impossible for anything to escape. The same fate awaits our universe, expanding at a rate much faster than the speed of light, which results in its boundaries moving further beyond the speed of light. Hence, are we trapped inside a massive black hole? Furthermore, every black hole in our universe may have multiple universes, each similar to our own. And beyond our observable universe, a more massive universe could be waiting for us. Our universe is merely a speck confined inside a black hole. Numerous theories have proposed the existence of parallel universes. However, the most prevalently accepted one in modern times includes a transformation of the precepts of string theory to include oscillating membranes that vibrate within additional dimensions. These undulating membranes situated in the 11th dimension represent whole new universes, and when these reverberations forcefully collide with each other, they create a novel universe altogether. The reverberating motion effect helps us better understand the matter distribution in our universe. One of the theory's most bewildering elements is that all the gravitational forces we experience in our universe are seeping in from another universe, situated in a completely different dimension. This might explain why the force of gravity in our universe appears so tepid when compared with other dimensions. As the universe expands and time marches on, it reveals novel galaxies and stars whose luminosity has only recently made it to our humble planet. However, these infant cosmic bodies will eventually wane, their brightness diminishing due to the effects of redshift that lengthen the light's journey through space. Ultimately, the farthest stars and galaxies will fade into obscurity, becoming invisible to our human eyes. Interestingly, the universe does not require an external perspective to exist. It simply is, and its mathematical self-consistency allows us to define it as a three-dimensional universe without needing an outside presence. The visual imagery of a universe depicted as a sphere drifting in the vast emptiness of space is merely a mental trick. But whether it be vast nothingness, a galaxy existing beyond the confines of a black hole, or bubbles, we may never attain a definitive answer to the question of what lies beyond. We can only assume and speculate. Avenues. And the discovery of new technologies has allowed us to see not just into the farthest reaches of the cosmos, but also into the behavior of matter and energy on the tiniest of scales. Surprisingly, research of these ultra-tiny particles that exist within the nuclei of atoms provides us a glimpse of the solution to an age-old question. How big is our universe? In ancient times, people saw the stars as a sphere enclosing the planet and the dwelling place of gods. Later, in the medieval ages, the Greeks were the pioneer to see stellar happenings as a phenomenon that could be studied by humans. A Greek philosopher and astronomer, Anaxagoras, proposed that meteors are formed of ingredients present on Earth, and hence the Earth may have originated there. The foundations of these astronomical studies were laid by those early astronomers. However, they would be astounded by today's discoveries produced by their followers. These stars and planets, which were once homes of the gods, are now considered as insignificant components of a huge framework of matter and energy that stretches far into space. We started making the most significant discoveries after 1920. In the 1920s, astronomers Edwin Hubble and Milt Hermansen were investigating the light of hazy patches of nebulae in the sky. This research used the massive new 100-inch Hooker telescope, the most advanced space telescope of the time, on Mount Wilson, California. They discovered that these hazy patches were the faraway galaxies far beyond our Milky Way. Moreover, they also discovered that the majority of these galaxies were traveling away from us. As they looked further into space, they witnessed that these galaxies were retreating faster. Hubble implied a law after an investigation that there must have been a period when all of the stuff in these galaxies was concentrated in one location. It is known as Hubble's law. In simple terms, everything that astronomers see through their telescopes can be traced back to a single origin. Later investigations term this phenomenon as the Big Bang. In 1917, Albert Einstein predicted the cosmos would expand. Based on Einstein's general theory of relativity, galaxies were moving apart due to the expansion of space. As a result of this, when a photon is ejected from a distant star, it travels across an already growing cosmic landscape, and thus increases the distance between the star and the Earth. Therefore, to determine the size of the universe since the Big Bang, we need to know how long this phenomenon of growth has taken place. Data derived by the Hubble Space Telescope and other instruments led to a conclusion that the emergence of the universe is 13.7 billion years old. Therefore, a beam of light may have traveled 13.7 billion light years. This equates to approximately 1.3 quadrillion kilometers. Scientists have been continuously exploring space, taking into consideration the expansion of the universe. The most distant galaxies that were observed by the Hubble Space Telescope were 46 billion light-years away in each direction, and about 92 billion light-years away from each other. Is it the maximum size of the universe? The answer is no. According to a new theory that describes the beginnings of the universe, our 92 billion light-year distance is just a tiny dot-like portion of the whole universe. This theory was based on the observation that energy in the form of photons, neutrons, matter and antimatter is constantly bubbling up from the vacuum of space. In the 80s, Alan Guth, a physicist, claims that energy fields in space's vacuum had unexpectedly flipped into a higher energy state. This has inflated space and time. Moreover, this proved that over an infinitely small period, space has grown from atomic to cosmic scale. The universe as a whole includes the observable and unobservable universe. According to Guth, the unobservable universe has grown to 10 billion trillion times. That's 10, followed by 24 zeros in size, compared to the size of the observable universe. That is 10 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Astonishing, right? To simply describe, the observable universe is an atom compared to the whole universe. The notion that our universe expands unevenly complicates these calculations even further. The European Space Agency stated in 2020 that the universe is expanding unevenly in all directions, based on evidence from several observatories. The researchers matched the brightness of thousands of galaxy clusters to their X-ray temperatures. Some clusters looked to have less light than others, implying that they were not traveling at an even speed. According to ESA, the enigmatic dark energy would be the reason for this uneven cosmic expansion. Humans may appear to be at the center of the universe. It is like assuming that the Earth is at the center of the universe. For example, if a ship is traveling in the ocean and cannot see the land, it doesn't mean that they are at the center of the sea. Similarly, we cannot define the position of the Earth, solar system, and galaxy in the vastness of the universe. The immensity of the universe is interpreted in several ways by scientists. It can be measured by studying the cosmic microwave moving in the background after the Big Bang. Moreover, it can also be measured by using Type 1a supernova standard candles. But all these techniques of measuring will only give us a rough estimate of how big the universe is. The rate at which this inflation is evolving has also become a great mystery. As assumed by the scientists, it was 90 billion light-years based on the assumption that the rate of inflation was constant. But many scientists believe that it is slowing. In the 1980s, Alan Guth estimated it to be 10 sextillions if the rate of inflation would be at the speed of light. According to NASA, these mysterious events of dark energy may have influenced the expansion in the seconds following the Big Bang. Rather than using a single measuring technique to estimate the size of the Earth, Miran Vardanyan, along with his colleagues at the University of Oxford, analysed all of the findings statistically. They used an averaging Bayesian model that considers how plausible a measuring technique is to be accurate, given the data, rather than how well the measuring technique fits the data itself. You'll be amazed to hear what they discovered. Miran Vardanyan and his team discovered that the universe is at least 250 times bigger than the universe that is observable through telescopes. Yes, you heard that right. This approximately equates to 6.8 trillion light-years. This calculation is quite big, but it is less compared to the estimates given by other techniques. The shape of the universe has a significant impact on its size. According to scientists, either the universe is spherical, infinite, or curved like a saddle, or it is flattened and infinite. According to the laws of physics, a finite universe will have a finite size that would be measurable. On the contrary, an infinite universe has no size. As of 2013, NASA scientists have determined that the universe is flat, with a margin of error of about 0.4%. This discovery can alter our perceptions of the size of the universe. Conclusively, the universe is infinite in size, but as the universe is finite in age, we can only see a finite portion of it. The whole universe is a multiple of the observable universe. In the end, we'll leave you with another mind-boggling assumption made by the physics department at the University of Oregon. They think that the seemingly limitless universe is deceiving us, just like a hall of mirrors. Light wrapped several times in space generates numerous reflections of each galaxy, which makes it look like the universe is infinite. Let us know what are your thoughts about this in the comments section. In 2021, NASA launched the James Webb Space Telescope. This measures the size of the universe by studying infrared wavelengths. As a result, we will be able to get accurate measurements unaffected by the particles in the space. Just 5 centuries ago, we believed the Earth was at the center of the universe. Thanks to the invention of telescopes, it helped us see distant stars, galaxies, clusters of galaxies, and huge walls and filaments of matter beyond them. Extending our perception of the universe far beyond our horizon has given birth to new conceptions about the vastness of the universe. It seems that these discoveries have pushed our planet into a smaller and smaller corner of creation. We hope you enjoyed the video. Don't forget to share this video with your space fanatic friends who would love to know about the size of the universe. Subscribe to our channel and click the bell icon to get notified of our newest videos on such interesting topics.